Hello everyone and welcome in the second video of ComfyUI and understanding how it works. So in the video today we're gonna do a very simple workflow. Now the good news is that a model just got released yesterday at the moment I'm making this video, which is called a Z image, and it's basically a model that generates very cool picture and doesn't require a big computer. It's the very first time that we see a model that is that good for such a low requirements, and this is the same model we're gonna use today because I prefer to use a model that most of the people watching the video will be able to run than something that's gonna be a bit complicated for the beginning. I really want this video today to be more understanding of how ComfyUI work and how we can get the first workflow working than entering the nitty-gritty just yet. We're gonna touch base the foundation, even though today we're gonna do something a bit more practical. But obviously there is tons of other video tutorial almost released every day about ComfyUI, new models and things like that. So please feel free to be curious, watch my video and then move to another one. If you really want to learn and you're really serious about understanding how to use ComfyUI properly and have fun with models, then YouTube is your playground, and there is the other website that I've shared in the past video that also have amazing resources for you to start or even just keep learning on. By the way, on this video I'm gonna assume that you already installed ComfyUI. If you didn't install ComfyUI, you just go on Google, write ComfyUI and install ComfyUI. I'm also assuming that you're good with IT, just at least good enough to understand what you're doing with a mouse and a keyboard. When you're in ComfyUI, the window is pretty simple, to be honest. You get your workspace in the middle, so this is the workspace. You get like some tabs on the left side on which you can click and get additional information. So when we're gonna start queuing for generation, it's gonna go into the queue over here. If you want to see the models that you've installed, you have them all over here. You can also check the console and see the data of your generation. We're gonna see that a little bit later. And you can manage a few things with by clicking on the logo over here. You can go into settings and you can change a few things concerning the way you want ComfyUI to feel and look. So for example, if you go in the lid graph, you can change the link render from the spline, which are normally what you're gonna get, to straight, which is what I prefer, meaning when we create a node, for example, we can see that here, if I select spline, then it becomes those little spaghetti. But if I go back to straight, then it becomes those straight line. You also have a top bar, which is, it has the manager. When you click on the manager, you'll be able to see that little window. You have custom node managers, you can click on it and then you can install custom nodes. Now, custom nodes are very important. If you remember the first video, we spoke about the fact that everything you do on ComfyUI can be done by code, right? And so those nodes are basically the front of embedded code. So each of those nodes runs something. So think about it like optimized tools, and we'll actually see a customized node today, and that will help you understand a little bit better why this is useful. Okay, let's start generating. So if you remember the first video, you remember what a clip, a val, and the diffusion model is. In this case, we don't need any Q version or any GGUF version of a model because Z image, as it is, as the full model, works very well on the very low VRAM machines. You don't need a killer computer to run it, and the result is really good. When we start our workflow to do that, we're gonna start loading the diffuser model. So we double click, and we're gonna search load diffusion model. Now we got our load diffusion model. Now we double click again. We're gonna start loading our clip. And then load again, and we're gonna load the val. All the links for the models are going to be in the description of the video. You just need to download them, and then what you will do is basically go into your ComfyUI folder, and in your ComfyUI folder you will find a folder called models, and you will put the diffusion model into diffusion model, the val into val, which is here, and the clip you will put it in text encoder. Not in clip, you put it in text encoder. Then when that is done, you come back on ComfyUI and you press R. That will request a reload of all the nodes, and then you will see the models that you've just downloaded available in those nodes that you've put in place. So here for the diffusion model, we're gonna use Z image. For the clip, it's gonna be Quen34B. The type, we're gonna use Quen, and the var we're gonna use the z image var. Note that I renamed the file. If you don't know it from the description, it will have a very completely different name. Feel free to rename it as I just did, just for less confusion when you start working with other models in the future. So if you remember correctly, the clip is what's gonna interpret your prompt. It's what's gonna understand what you're prompting. The var is what's gonna take the result of the model and make it visual. So here it's extremely simple. Every time you take the output of a node, you can just click on it and drag it. And then when you stop dragging it, it gives you a possibility of nodes that can attach to that one. So all that you see, all that list that you see are only nodes that are compatible with the output of that specific one that we just did. So the load clip, by stretching and dragging the clip output, it gives us only nodes that can take the input of that specific node. So in this case, we need the clip text encode prompt, because we need to prompt. Then from the model, we need a K-sampler. So you have the K-sampler and the K-sampler advanced. I personally prefer the K-sampler advanced because you can do much more control. So we're gonna use the K-sampler advanced. And then as you can see here, now our nodes have a entry point, so an input and an output. So input are on the left, output are on the right. And it's basically extremely simple. So here, for example, if I go on conditioning and start dragging it, we can see that only positive and negative can receive the input of the prompt. If I go on latent image, we can see that nothing can receive the input of this. So it's basically like Lego. You just connect things to them. You obviously need to make the right connection, but you have a visual cue on top of very simple logic of input and output. In this case, we're gonna do the conditioning for both the positive and the negative. A negative prompt means everything that the model is not supposed to do. Now, this is slowly changing, and more negative prompts are not being used in models. And in this case, it's exactly that. Note that if you wanted to create a negative prompt, you could do one thing, which is you can duplicate the prompt here by pressing Alt and then dragging the node, which duplicate the node, and then you can connect clip and then conditioning to negative. You can do that and you can try it. In this workflow that I'm making with you, I'm not putting the negative. I'm gonna use the same prompt for both the positive and negative. But again, feel free to try out things. Feel free to just babble around once the video is finished and just try to do things. Now that we have our model connected to the K-sampler and the prompt connected to the K-sampler, we have this last things called a latent image. A latent image is basically a canvas on which the model is gonna start painting on. So in this case, we need an empty image with the dimensions that we want to give the final image. So you're gonna drag the latent image to somewhere. And here we can see empty latent image, which is perfect. This is what we need. We need an empty latent image, a blank canvas. And we're gonna have 512 by 512. You can change those values by clicking on it and changing the value directly. In this case, we're gonna stay with 512, 512 for the moment. And here we see that the output is a latent image. So this is, the latent image is basically the mathematical result of all the operations. So if you remember correctly, in the first video, I was saying that the model is gonna do a lot of mathematical decisions and you don't see the result. You have to use the var to give the result, the visual result. So it's exactly what we're gonna do here. You're gonna take the latent, and here we have the var decode. The var decode is gonna take all the mathematical data that has been generated in the K-sampler and give you the final image. And in this case, we obviously need to connect the var to it in order for the var decode to understand, okay, which var do I need to use? And an image, we can do preview image. You can also choose save image if you want to save the image, but in this case, we're gonna just preview it. And for the prompt, I'm gonna write, a guy sitting in front of his computer in a dark room doing a YouTube tutorial. The guy has dark hair, dark short hair, a black t-shirt, and has white skin. And I'm gonna run this workflow. For that, you just click on run. And we got our image. And the result is pretty good, as you can see. This is what's beautiful with Z image, is that you get very quick generation, as we saw sub-second, and the result is actually pretty good. We can obviously increase the resolution, 1024 by 1024, and I'm gonna rerun it. Now, obviously, The higher resolution you go, the better quality you're gonna get. But don't obviously go too crazy with resolution, because obviously it requires more resources. As we've seen now, it took a little bit longer to generate than the 512. Usually people generate images or videos with a very low resolution, the resolution that is sometimes perfect for the model. So for example, you have models like 122 that is made to generate videos for 480p and 720p. But if you want a video that is 4K, then you're gonna generate 720p, then you're gonna upscale with other techniques and workflows that you can use on ComfyUI to take your 720p video to a 4K video. And the same with images. Now that we have a working workflow, we're gonna go through all that we see over here. As we can see here, we have on the case sampler a bunch of things, a bunch of data. The noise seeds is basically the random factor of the generation. So in this case, it's randomized. We can say that the control after generation is randomized. If I put fixed and I generate, it's gonna generate the image with this random factor of the noise seed. We're gonna see the result in a bit. Okay, there you go, we got the result. But now if I run again, because the seed didn't change, it's gonna give us the exact same image. You see, it doesn't even run the prompt because the output is already known. The random factor has not been changed at all. The steps are going to be the amount of time the model is supposed to go over the image. So in this case, for example, if I put 4 steps and I run again, it goes extremely fast because the model doesn't have to do the calculation 20 times, but only 4 times. But we see that there is a little bit less quality on the image. The CFG is kind of the control of the prompt over sampling. So in this case, for example, if I put 1, it's not gonna affect much in this case. It's more like for specific models like Flux 2 and others. CFG is gonna kind of affect a little bit the quality of what you're doing. So I will advise you to always have it between 1 and 3.5 maximum. But again, when you're gonna be on CVTI or other websites where you're gonna download LoRa's or different kind of models, they will tell you what's the best CFG parameters to put. Again, usually they don't go over 3.5, but again, depends on the model that has been trained. The sampler and the scheduler is basically what's gonna happen to the calculation themselves. This is the algorithms that are being used to generate the noise and then make sense of the noise on the blank canvas you gave. So the latent image is coming here blank as a blank canvas, and then those algorithms, like with the noise being projected on this blank canvas, those algorithms is exactly what's gonna make sense to them. In this case, for example, usually for imagery, we're gonna use DPMP. For example, here we're gonna use DPMP2M, and scheduler we can use, I don't know, Keras just to test. The result might be absolutely horrible, as you can see, and you see how it affects the final result. Here, if we take beta 57, usually the result is gonna be a little bit better. We can see that it gives us this kind of weird details. It's a bit better and at the same time not that much. And you can just play around with those parameters until you find the thing that really is to your liking. You see, like here, the 3M SDE with beta 57 is pretty good. The screen makes a little bit more sense, not that much, but still we have a little bit more details over here. We go exponential. I'm doing completely random stuff right now just to give you an idea. Now let's say that I want to upscale that image. I want to upscale this image to 1080, for example. What we're gonna do is we're gonna go into the manager. We're gonna go into the custom node manager, and we're gonna use an upscaler called SeedVR2. So you're gonna search SeedVR2 and you're gonna download the video upscaler. You're gonna click on install. Once it's installed, it's gonna ask you to restart your ComfyUI. You're gonna restart your ComfyUI. Note that when restarting your ComfyUI, sometimes ComfyUI bugs and just stay gray. It's not a big deal. You just restart ComfyUI again, and at that moment ComfyUI will start and you will get back on the workflow, and so you will have the same thing again. And if you don't, just put back the workflow as you want, as you wanted. And then for here, we're gonna take from image, and now we're gonna search SeedVR2, and now we have the node. Now the node is visible. Note that this node is mainly made for video initially, so we're gonna use this node as a complete example. There is much better upscalers available. It will take a little bit more time to explain, so let's just go with SeedVR2 for the moment, and then you're more than welcome to find more videos or wait for me to release a better video on upscaling your pictures. So here, just like the other nodes, we get input and output. The output's gonna be the upscale image, so we're gonna do a preview as well. The input here is the DIT and VAE model that this specific node takes. So for that, we're gonna do this. And now why I'm using SeedVR2 is because it's super simple for making a tutorial on YouTube, because you literally have nothing to do. In this case, we're gonna search SeedVR. It's gonna tell us that the only SeedVR2 input node that is compatible is the DIT model, and it has the download into it, which means that in this case, this node is gonna download the model if you don't have it on your machine already. So it's all automated. For this tutorial, it's perfect. Then we're gonna do the same with the VAE, and now here you go. We have everything to upscale our pictures. So now one thing that we can do is another simple techniques. We're gonna put the preview over here. If you click on a node, you can see that you have this little play arrow over here. So if I click on run, it's gonna run the whole workflow from scratch, from the beginning, and restart everything from scratch. Now, I don't want this personally, even though it will not generate a new image since we moved on fixed, but I just want this specific output to play. So if we didn't had it on fixed and I just want to see the preview of my upscaler, by clicking here instead of the run here, but just on this little play button here, it will understand that it needs to take just the output of that specific node. Basically, it will understand that it just needs to fill that preview image. So we're gonna do that. We're gonna click here, and now it's upscaling the image. And now we got a 1080 by 1080 image, and we can see it has a little bit better quality to it, just a little bit better. You can obviously change the resolution, just make sure to understand that upscaling is heavy on memory, so your computer might not have enough RAM or VRAM to process it. Now, there is parameters you can play with in order to kind of go around those different kind of restrictions that you have on your computer. You can do something called a block to swap. So for example, here you could put it for 36, which means it's gonna swap some of the blocks that are your VRAM back to your RAM. But again, if you don't have enough RAM, that's not gonna work. There's few things that you can change here. You can change the batch size if you have a bigger computer, and you can enjoy faster performance, and you can increase the size of your batch in order to process the image faster. Because basically the way an upscaler works is that it's gonna tile your image, so it's gonna cut your image in different tiles and upscale each of those tiles one by one, and then reassemble the image by itself. So we get pretty much the handle here on how ComfyUI works and how you can have fun with some image generation. And that is all for the first part of the video. In the second part of the video, we'll find out how to make the workflow that we just created readable and understandable by your friends, your peer, and your team. But already with this first part, you've learned how to use ComfyUI and create your first workflow that is working and generate your first pictures, whatever configuration you have. So even on a potato PC, that will work. I hope you enjoyed that video, and I'll see you for the next one, probably beginning of next week, because basically I already recorded the next one. It's just that the video is way too long for me to put it. It will be like 30 minutes, so I'll just put it in 2. It's great, it gives me more content, it's very good. I'll see you next week. Enjoy.